All right, we're going to take a few minutes to look at maybe intermediate SQL querying, queries where you have maybe a set of records that you're going after or a subset. And that kind of happens a lot when you have one-to-many and many-to-many relationships. And it's part of the power of SQL then to be able to almost perform some business intelligence type of things or some summarization and that kind of thing. And it's best, in my opinion, to dive in and see it by examples than yeah, just kind of stand at the edge of the pool talking about how good it's going to be. So aggregate queries summarize subsets of records, usually based on a group by, or you use the group by clause to say, for every individual, in this case, year, I want you to do something. Every column selected, right, needs to either be an aggregate, like where you're summing something, minimizing, counting, maximum, average. Those are the five that we have in T-SQL. Or they need to be something that you group by, right? And, a mistake, if you see, and always look at your errors, it's not a mistake, it's just, okay, if I just tried to run the query at this point, select year and the sum of the amount from gift, I get this thing, okay, gift years is invalid in the select because it is not contained in an aggregate uh, function in the group by clause. That is, if I try to sum amount, then I've got multiple years or potentially multiple years, and I've got to give the system something to do with that. I could maybe select the first year or something. Yeah, but this by itself doesn't make any sense. If I add the group by year, then it does make sense. If I left the year out here and I just said some amount from gift, then I'd get that grand total that I wanted, but it doesn't make any sense to ask, this year is going to be a set of things, but if I group by it, then I get one total for each one. All right. And I think that's pretty much, kind of the sense of how the group by works. There's some tricks of the trade and some subtleties. Sometimes you group by things that really don't help the grouping. Here I'm trying to select donors, and it's always unclear when you say get something like, okay, select donor, I have donor ID, last name, first name, street, I don't have a city, I have a state, and a lot of information. So for me, I took that to mean the donor ID and the name. Okay, so this one, I'm just show donors and the number of years they've donated. Okay, so here, so what I've decided to select is I want to see the donor number. And then remember this concat thing, that just shows their name as a quote, a regular name, assuming we have first name and last name. Names are very even variable from this. And, some of the names I see on rosters, I can see come from cultures and languages a little different than from our tradition, which is great, but sometimes it can't all be hammered in. So I put that concatenation and called it donor. Then I use the count. And usually when I count something, I count the column name or the that I want counted. Actually, if you put star, so it's really not counting the years; it's counting the number of records that fit into this, you know, into the result, and then it's going to give this name. We're doing this inner join, right? Gift. The donor on gift, so we have all the donor information, but then we have the years that they donated, and it all works out. And I will demonstrate that. I've got a couple of cats trying to fight over my lap here, so excuse me for a second. But there we go. So I got donor ID, the donor name, and the number of years that they donated. We could check the the data I have that is correct. Something you ought to do. And in fact, in this exercise, when you do it, I've asked you to add data that tests to your satisfaction that it's doing the right thing. But here was my point of this. If I group by donor ID or donor number here, well, that's going to necessarily group by the last name and first name because that's they're going to go along. They're in a one-to-one correspondence with donor ID. But if I don't add that, if I try to submit and that's all I had, I'm going to get this error that, okay, the first name here and the last name that I'm using up here aren't part of a group by, nor are they part of an aggregate expression like a count. Something I liked about Access that is not in T-SQL, they had a first aggregate or a last aggregate And what that would do is just the first one that came along. So we know that in the set of records for a particular donor, the first name is going to be all the same. So first we'll just say, we'll grab the first one you have. It's as good as the last one or the middle one. And that kind of thing, but T-SQL doesn't have that. So the kind of thing is we group by last name and first name as well, kind of within donor. It's kind of, think of this as main, next level, like a sort almost. So you include things, in here that I really don't need to group by them, but you do need to group by them if you want to refer to them in your select. Okay, so that's just this, and I've already talked about the count, and we've talked about aliases before too. Makes for a neater display. Something else that went on here, up here I wasn't particular about which table. Well, I guess that in that case it was only one table, so from gift, so that didn't matter. But here we've got the join, and there's a donor number, donor pound on the donor table and the gift table. So when I select, I have to put donor dot donor number, or gift.donor, choose one or the other. If you just do it like this, then it's going to complain, oh, that's ambiguous, okay, because I don't know where you're getting that donor ID from. And so if you ever get that ambiguous, then just I usually choose kind of what the key table is. In this case, since we're doing an inner join, it's not going to matter. The donor number is going to be the same. It's matching them, for goodness sakes. It's going to be the same, but I like to do it this way. It kind of relates maybe to this next one where we want to see everybody, but I think about the key table. The donor number is really the key on donor, so that's where I would choose it to come from. And I needed to repeat it in the group by, because donor number, there's also a gift.donor number. Right. So as I say, you get used to it, but okay, scratch your head and all like that. Remember, sometimes, when you produce a list for a user, or maybe you're giving something for somebody to use in a web page or something, they say, well, gosh, what about, now I wanted everybody, I wanted all the donors, okay, and tell me they did 0 donations if they didn't, but I wanted to see the full list. So it turns out that this donor knew Adams hadn't donated at all. Now, remember, in the data model, that just means they didn't have any gift records. And we looked at last time how we could do an outer join and then coalesce this count. And remember, on using the outer join, then the year number is going to be null for those that don't have anything. And the coalesce says, well, if the year number or the count of the year number is null, and if you count something that's null, then you get a null, then count that as 0. So, that's where we can just be sure. And sometimes it's not absolutely clear from the context. Then you might go back to whoever, provided you the requirements and say, well, what were you looking for? Or I guess if you provide this one, then they can always filter it out for, no, it's just one of the ones where it was at least 1 year. And that was right. And you can always add an order by. I did that here. So here, even though this is the donor record 3, and without the order by clause, it would have come in a different order. I think probably by donor number. You can't count. If you don't have an order by clause, you can't count on what order necessarily these records will come back in. That's part of the SQL statement. So if you need it in a particular order, then be sure you add an order by clause. But just showing that you can kind of add that on top of there. All right. Familiar with the where clause, want to go into the having clause. The having clause filters aggregate values. Okay. So we're going to select the donor and the year, kind of like we did before, just like this guy up here, but we want just those where they've donated 2 years or more. So the way you do that, it's not a where. Remember, where sort of filters think of as the input or unaggregated records. It's having, and we just say having, then this count bigger than or equal to 2. And so, it's just an extra clause you can add on, kind of like a where clause, but having operates on an aggregate, whereas where operates on just, say, one of the columns. One of the things you can't do because it's really not been instantiated, that almost feel like, if you program much, that why couldn't I just say number of years donated greater than or equal to 2? And it turns out that this really isn't like a variable name. It's really just an alias or a column heading, and it's not available. So you kind of have to repeat that aggregate, even if it's a complicated expression, down in your having clause. Okay, so but having just checks that an aggregate is at some level or another. You can combine where with having, right? So this one, we're just looking, remember these are, the amounts are the annual amounts. So we're now counting the years where the donations exceeded 1,000. Okay, so the where just says, well, don't include anything where it wasn't 1,000. And okay, that's just a where clause, but you can have where and having at the same time. But this is just a where. So if I do this guy, then I find that Joe Blow, and I think if we go to the other one, we can, or look at the amounts. Yeah, we could look at the amounts, just the gifts. Let me just, we don't know who they are, but there's only one that exceeds 1,000. That's donor number 1, who happens to be Joe Blow. And oops, let's get back to here. And so, yeah, so there's only 1 year that is greater than 1,000. Just showing off here, what if we want at least 2 years where the gift was bigger than 1,000? So here I'm just showing off you can combine where and having, and in the right context, it makes sense. Just as an aside, I didn't add records. There's nobody who did equal to or more. This one's greater than 1,000. Notice the wording, at least 1,000. So just, make sure you're doing something. The greater than or equal to could be very important. And be sure you're getting what they ask for. But some queries, might turn nothing and still be correct. So the fact that this didn't turn any records on these data is exactly correct. There just might not be that fits anybody that fits the condition, but that's where I kind of go back to, if I were developing this query for an assignment or something, I would go back to the data and maybe add enough data in here to see that that returns something, just to let me believe that the query is operating correctly. All right, so where and having can be combined. We looked at subqueries briefly earlier, and they can get subtle and deep, and sometimes that chapter goes too far, like subqueries 4 up to get some set theoretical thing to happen. I mean, it's a beautiful sort of mathematics, but 90% of working with databases that doesn't get down into some of the advanced set theory things that can happen. I'm not saying that's a bad thing to sort of appreciate and be aware of and dive deep into if that's your knack, but you should understand the idea that you can have a select within a select. And so this one's going to be show donors in year and amount, right? So this is nothing more than, the donor, their name, the year, and the amount. But what they did was contribute more than the average of all the amounts that we've ever seen. So we can, that's a query in itself we're familiar with. If I said, just what was the average amount of all gifts? You might know after a little head scratching, okay, that's how I do. That's going to return a number. So, this is, selecting then from this inner join, looking at each amount given in a year, and saying, oh gosh, is it bigger than that average? And we can run it and see what we get. Here we might do some calculations on the side. But if you remember the records, I don't know what the average is, but this 5,000 was about the only big one. The others were smaller, so I'm believing that that's the right thing. The important concept here was kind of sometimes using a subquery to kind of get what it is you're after. This specific value, you're sort of kind of going back to the well to get something, going to the same well twice. Now the query analyzer, the way the database engine takes care of this is fantastic, and you'd have the deep subject and database programming to get there. But it looks at different ways it might calculate this, and comes up with a best way and does it. So it doesn't necessarily do it the way you might think. Well, first calculate this, and then plug that in, and then do all this, and it might even look at the joins and figure out a better way to get that. And so I'm not saying thinking about how you structure your queries isn't a good idea for efficiency, but we state it. What we get guaranteed is we get a result that meets the SQL, not that it calculates it this way. But there's the idea of a subquery. And the chapter goes into this exists operator and not exists. Okay, the way we kind of in the past have maybe showed donors who didn't make a gift, we could do the outer join and look for null in anything from the gift table. Another way, and it's really usually exists based on a subquery. So select donor number from gift where, and here we kind of have a tricky thing. This donor number here refers to the from gift, and this donor number refers to this guy up here. So we got this, but if we just have a specific donor number in mind, this one selects the donor number from gifts, and there might be multiple of those, but exists just says, oh, if there's one or more, then this turns out to be true. So exists blah, blah, blah is, yes, there's one record or more for that donor number, and it's just an aware clause. And who've not made a gift, well, not exists, right? And so it is just kind of an operator that works on a subquery to help, to me, get something done that you need done with what you're trying to do with your query logic, to get the right records back. It's also the basis for some of the set theoretic things that you can do with the database that are kind of fantastic too. But I usually think of it as I just need something where a thing exists or doesn't exist. So again, that's a subquery, a select within a select, pretty powerful, and it can go levels deep, probably 2 or 3, in my opinion, is all you really will ever need in real life. Okay, kind of getting to the end, realize that joins can involve more than 2 tables, right? So maybe we wanted the year, I meant annual donation goal. These are my notes now, so I'm going to give them to you. The donor, the amount, and the amount as a percentage, and I just did it with donor number here as a percentage of annual for all donations. So, there's donor, inner join, gift, where the donor number is equal to the donor number on gift, but then I can interjoin that, that results in a relation, right? Think of it as a virtual table, columns and rows, and I can interjoin that with year on that the year of the gift matches the year involved on the year table. And remember, it was the year table that had that year goal. So there we are. So we had 10,000 in 1999, and this 500 was 5%. I didn't format it as a percentage, so 0.05, but it did. But it's combining information from every table. Actually, I guess the way I've done it, I didn't need the donor table because I can get the donor number from gift. But if I wanted to have the donor name, say, in this table, it would need to be, I would need the donor table. But now as I look at it, since I didn't include that donor name bit, I don't know if we need the space there. That's not where I wanted to put it. Yes, I know. Little grumpy. There, something like that. Now I need the donor table in there to be able to get the name. All right, so, but it can involve more than one more than 2 tables. Something that helps with that sometimes, and I use it occasionally when I'm doing SQL. I've just right-clicked on a blank spot and got this query design. And the nice thing is if I put in all the tables, then SSMS, the Management Studio understands, okay, there's these joins, these foreign key relationships that they've established. So they've pulled in these tables. I'm going to pull in the foreign key relationships that already, that apply, that are probably what they want when they're getting started. What this does is, it saves a lot of kind of typing and remembering what the keys are, because it kind of remembers, for you. And what did we have? We had year, and we had the donor number, and you can click on columns you want. Notice it's coming down here. And kind of showing in. You can type formulas. Usually what I do is I get started, then do OK. It squirts in the SQL, and I, kind of go from there. You can put filters on. That would be a where clause. You could do a sort order, a sort type. That's ascending or descending if you just, kind of needed help with that. And the filters can be this or that. Getting good at this query designer isn't, I think, a great goal, because there's some things you can't do, but for getting a start, for just having to type that all in. And I think you can even, add a group by in here, and, it kind of, figures out. So if you kind of forget how the group by comes in, and there's even some, you can add a having, I think, but there's and there's other kinds of quote queries, things that insert records and that. So it's kind of grouping by, or you can maybe add, here's where you add the aggregate operator if you wanted. No, I wanted to, for some reason, sum the donor number. All right, so that's a little bit bogus, but it did help a little bit with kind of, okay, I don't remember all the syntax, or I kind of remember the syntax, but boy, typing it all out, getting the parentheses, sometimes that QBE is a little bit handy. I'm just going to comment that out because I'm not even sure it will run the way I've got it. Just was demonstrating how to go it. Good. And my last comment on, maybe especially on that query designer, is where the sophomore join. And the sophomore join is where, let's see. So I've got to list all the donors and the years, right? That they've, donors and years, that just the donor IDs, design query and editor, and the years. Well, the sophomore join, in my opinion, is where they aren't watchful about, have they got the kind of the intermediate tables. So it is possible to just drop the donor number and donor table and the year table in, and say, well, I want the donor number and I want the year number. And that all looks good, and that's good SQL, and blah, blah, blah. And then just, okay, there's my query. Okay, looks like everybody donated in every year, and that's not right. And so what they weren't paying attention to was needing that intermediate table if they were going to include all of them. Of course, if you're really on it, you might right-click here and add the gift table in, and the gift table is sort of the moderator so it's really kind of an inner join, and that would be the one that lets us see that, okay, not everybody donated in every year. I was just saying, if you're really on it, if this is all you wanted, you don't need the inner joins anyway. You could get all this just from the gift table. In fact, that ends up being pretty much the list of, select star from the gift table. But sometimes when you're using the query designer, you kind of maybe don't realize the tables in between that link up everything together need to be included. All right, just some thoughts and examples. Scratch your head and you can go with it, but good luck getting that assignment done. Of course, questions, let me know.